Today's lesson corresponds with the last lesson on 13.1 with sequences, arithmetic and geometric. Today we're going to talk about using sums of these arithmetic series. So we're going to be adding these sequences, which in turn create what we call series. So knowing this then, what is a series and what is a partial sum? Well, the sum of the terms of a sequence is called a series. Usually we're going to be talking about a partial sum because we're not going to add all the numbers in a series or a sequence because the sequence probably may be infinite. And if it's infinite, then we can't do a definite sum as we know it. We will in the next section discuss this, and actually our last section of the year we will discuss that. So the sum of the first sum would be a sub 1. The second sum right here is a sub 1 plus a sub 2. The third sum is a sub 1 plus a sub 2, etc., until you get the summation of n, which is equal to the sum of all the parts of the sequence. So the formula for the sum of a certain kind of arithmetic series, if you think about this, if we go to n terms, then this one is n minus 1, it's one less, then this one would be n minus 2 and n minus 3 and so on. So what we're going to do is talk about how this formula comes about, where we're just pairing numbers. This is what Carl Friedrich Gauss did when he was a little kid. I think he was about 7 or 8. Got in trouble, and the teacher told him to, and this was in the 1700s, told him to add the first 1,000 numbers, and he did it in about 8 seconds. And what he did was this method. He took 1 plus 1,000, 2 plus 999, 3 plus 998, so etc. And then what you get is 1,001. How many times? 500. So he could do all that math in his head that it was 500 1,001s. Well, this is the same concept. So if we do the half-n pairs, then we end up with this formula, which is 1/2 n times n plus 1. Or another way you might see it, n times n plus 1 all over 2. It's the same formula. So this is our sum of all arithmetic series. N times n plus 1 all over 2. Or special arithmetic series. And we'll get to the overall sum here in a second. So if you sum the first 1,000 integers, it's 1,000 times 1,001 divided by 2. 1,000 times 1,001 divided by 2. And so it's 500,500. Now, if the number of terms was odd, and let's say we were going to find 845, so 845 would be the last number, and we would just take the sum of the first 844, which we would use the formula 1/2 times 844 times 845, then add 845 and get 357,435. So all this is showing you that there's a special formula that we can use to find the sum of these types of arithmetic series. Now these types, notice they differ by 1, but obviously not all arithmetic series differ by 1. Because of that, and you can go through this if you want, read through it, this is actually the formula we're going to use right here. 1/2 n times the quantity 2 times the first term plus n minus 1 times the common difference of the terms. That's what that formula means. So before we get into a summation, let's just think about a sequence that we could add, and then let's see if we can find the sum of it. Okay? So let's get a simple one like, let's see, how about 1, 4, 7, 10, 13, 16, 19, 22, 25, 28. How many is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We'll go one more. We'll go 11 terms. Okay? So remember, our formula was 1/2 n. The sum is 1/2 n times 2 times the first term plus n minus 1 times the common difference. Now you can add all these up if you want. Let's do it by hand. 5 plus 7 is 12. 12 plus 10 is 22, 35, 40, 51, 70, 92, 117, 145, 176 if my math is correct. Now let's test the formula though. So let's see how good the formula works. So we have 11 terms. So we're going to take half of 11 times it times 2 times the first term plus 11 minus 1 times 3 because the common difference is 3, right? Each one of those. So that's going to be half of 11 is 5.5. This is going to be 2 plus 30. So that's going to be 32 times 5.5. Let's see what we get. 32 times 5.5. And I don't know that I get the right answer. 176. Oh, look at that. 176. So it works. Well, you don't want to have to add all these up by hand. So here's the formula we're going to use. That's the sum of any arithmetic sequence. That is the formula. Right there. So you might want to pause this and write that down. Okay, you're back. Now, summation notation. Oh, you've been waiting for this. The Greek letter sigma, this is the capital letter sigma, stands for the sum of a sequence. Okay? So right here, this says the sum of the sequence A sub I that starts at I equal 1 and ends at n. That's how you read a summation. The sum of A sub I with I equal 1 ending at n. So, whoa, what is all that? Well, let's talk about it. So if we use sigma notation to write the sum of the first 20 positive odd numbers, okay? And again, you can look at the reading here, but I'm going to do it over here. 20, the sum of the first 20 odd integers. Sum of the first 20 odd integers. Okay, so that is going to be the sum, sigma. Let's see, they got to alternate by 2, right? So you have to add 2 each time if they're odd, or 1, I'm sorry. So what if we said the first term and add 1? Well, let's see, how are we going to do this? Oh, sorry, not A sub I. That's not what we want. We want just I. There we go. And we're going to start at 1. Well, that won't give me odd numbers, though, will it? Well, that won't either, will it? Oh, I know what we got to do. So what we got to do is we got to come up with a formula that's going to give us a 1 to start with and add 2 each time. So it's going to have to be, let's see, 2i plus 1, let's say, and start at 0. So 2 times 0 is 0, plus 1 is 1. So there's the first term. The second term would be 2 times 1 is 2, 2 plus 1 is 3. Okay, I think we got it. The third term would be 2 times 2 is 4, 4 plus 1 is 5. Okay, so this is your equation right here that you're going to use. But we have to start at 0. Well, if I need 20 terms, then we would stop at 19, because 0 to 19 is 20 odd integers. So this is written then in sigma notation. Now, I'm just going to tell you there are a lot of people that will have something different there. You could go, let's see, how about 2i minus 1 if you started with 1? Would that give you the same thing? So a sub 1 would be 1. Yes, it would. A sub 2 would be 3. So you'd go 1 through 20. So both of these work for the summations. But this is, again, how you read it. The sum of 2i plus 1, I starts at 0 and ends at 19. This one's 2i minus 1, I starts at 1 and ends at 20. But we still get the same sequence. And that's all that matters. And I'm stopping at 3 because I know it's going to be 7 the next one, etc. Now, if you recall, the formula is up above to find the sum. 1/2 n. So the sum of the first 20 odd would be 1/2 n times twice the first term plus n minus 1 times the common difference. So we have 20 numbers. 2 times the first term, 2 times 1. So 20 minus 1, I think, is 19. The common difference is 2. So let's see what that sum is. That's 10, half of 20. 2 plus 38. I got 400 because that's 40. So check my math. I'm pretty sure that's correct. Now, what's beautiful about this is our calculator will do this for us without having to use the formula every time. Now, I encourage you to use the formula a couple times, but you don't have to when you have this nice calculator. So if you go to Math and 0, Math 0, and it says summation. Now, if you have a newer calculator, it automatically does this when you hit enter. You get a box equal a box over a box. Okay, and then you have a parentheses with a box, close parentheses. So what goes here is your formula. What goes here is your variable, which we would use x in this case, so you would, because that's easier on the calculator. So you type in 2x plus 1 if you're going to use this one, but you would go x equals 0 and end at 19. Now, I don't have an 83, so I am not entirely sure what that would look like. You're going to have to ask me in class, but you definitely want to know how to use this feature in order to evaluate. Now, I'm going to go ahead and do this one, 0 to 19, and I'm going to use 2x minus 1, or sorry, 2x plus 1, and I'm going to see if I get 400, and it's 400. It equals 400. So it works. So you can use the calculator here or the formula here, either way. And we could use the other one too. I'm going to go ahead and do Math 0 summation. I'm going to put x equals 1 this time. And I'm going to put to 20. I'm going to put 2x minus 1 and see what the sum is. And it is also 400. So we did it correctly. So both of those formulas work. Okay, your problem set is on page 546, 13.2. And you are to do those numbers, 1 through 14, 16, 18, 21 through 25, 30, and 31, and 42 for next class.